Okay, so for today's lesson, we're going to be going to infinity and beyond. I'm just kidding, you can't actually go beyond infinity. In fact, you can't even go to infinity. So we're going to figure out in today's lesson what Buzz Lightyear had wrong in this lesson about infinite limits. Okay, so an infinite limit is basically going to look like this. The limit of f of x, so you're going to have the limit of some function as x goes to c, as x goes to some number, is going to be equal to infinity or negative infinity. Okay, and I have an example over here in red that kind of shows this. We have a vertical asymptote created by the function, and if you remember your vertical asymptotes rules, it's basically where you have some function, f of x, that's what this red function is, and you take the numerator divided by the denominator for the rational function g of x and h of x. At some point a, g of a would not be equal to 0, however h of a would be equal to 0. And that's kind of how we defined our vertical asymptote before. Whenever g of a is not equal to 0 and h of a is equal to 0, x equals a is our vertical asymptote. To kind of put this in calculus terms, I wrote down a little note right here about this. If you take the limit of f of x as x gets closer to a from the left side, so right over here, it's going to infinity. And then if you do it from the right side, it's going to negative infinity. That also can define your vertical asymptote using calculus this time. Okay, it's basically saying the same thing. Now you don't have to have a vertical asymptote in which one goes to negative and one goes to positive infinity. You can have them both going to positive infinity or both going to negative infinity or one of them just going to positive infinity. But for this case, or negative, but for this case, I both have positive and negative to create the asymptote. Okay? Now to kind of compare asymptotes to wholes, because sometimes kids get confused with those two, I have another function here in blue, m of x, which is a rational function n of x divided by p of x. N of b, so I have this b right here, is equal to 0. And p of b is equal to 0. So you have this indeterminate 0 divided by 0 at this point. That's what creates the whole. But if you notice, there's no asymptote for this. Here there's an asymptote. The limit does not exist. But if you take the limit of m of x as x is getting closer to b, there will be a limit. So that's kind of just using that to kind of compare wholes with vertical asymptotes, because sometimes kids get confused with that. Okay, so if you have any questions about infinite limits, let me know.